Let's look at our next example. We have potassium chlorate. So potassium is in group 1, so it would be K plus 1. Chlorate ends in ATE, so it's a polyatomic. I'm looking at page 7, ClO3 with a -1 charge. So when I cross the charges, I get KClO3. Decomposes to forms. So all of that right there is that arrow because it's turning it in. The potassium chlorate is turning into two other products. So there's my arrow. And then we have potassium chloride. So potassium in group 1 plus 1. Chloride. IDE tells me now it's the element, not a polyatomic. So this would be Cl minus 1. So we have KCl and plus oxygen. Now oxygen is an element, so I have to think to myself, is oxygen a part of Hofbrinkel? And it is. It's the O of Hofbrinkel. So it's not just O, but it's O2. So you have to put that subscript there when oxygen is by itself. In other words, it's not in a compound. So then we need to balance it. So we're going to draw the lines for our coefficients in front of our substances. You cannot put numbers in between elements. You have to add a coefficient in the front that would then multiply the subscripts. We're going to practice that inventory style. So we have 1 potassium. Notice that the polyatomic ClO3 does not show up on the product side. That means we need to break it apart and balance each element individually. So we have 1 chlorine and 3 oxygens. On the product side, we have 1 potassium and 1 chlorine and then 2 oxygens. Notice that I'm listing them separately as opposed to in one big list because I want to make sure that when I put a coefficient in, I know what is being multiplied and what is not. So now let's look and see what doesn't match. Well, we have 3 oxygens and 2 oxygens, so that doesn't match. I can't multiply anything by 2 to get 3, but what I can do is use the least common multiple of 3 and 2. So 3 and 2's least common multiple is 6, so I can make them both 6. So I'd have to multiply this by 2, so times 2 times 2 times 2, and I get my 6 oxygen. And then I would multiply by 3 on this side. 3 times 2 is 6. So the oxygens match. But now the potassium and chlorine don't match. So we have 2 potassiums, 1 potassium. So we're going to multiply by 2. 2 times 1 is 2. 2 times 1 is 2. Now everybody matches. We have the same number of potassium on both sides, the same number of chlorine on both sides, and the same number of oxygen on both sides.